Okay, students, now I will be talking about a very important topic, that is mechanical relay and solid state relay. So the figure that is shown over here is mechanical relay. Students, serious thing, we need to understand it very carefully because none of these university lectures are available on YouTube or Google. Only on this YouTube channel you will get all the videos which are underrated and not available in all the YouTube channels, are not easily available. If you get this, you're very lucky now. So at first, let me discuss about the mechanical relay. It sounds a bit complicated right now. You are also seeing here, I'm sure not understanding anything, but trust me, once I need to understand, you will understand. Just have that belief, have that patience, and just go along. So here is a coil. Alright, we all know that what coil is. This is a conducting element. Here is a voltage source. So when this voltage source is active, the coil will conduct. And when this coil will be conducting, the switch, this will be pulled downwards, which will also, the switch is like this pattern. So when it's pulled downward, this part will be pulled upward, and when this part of the switch will be pulled upward, it will press or will push this conductor wire towards this conductor wire, the left end of the conductor wire to the right end of the conductor wire, which will just complete this circuit, and this circuit will begin to flow. So why we are using it? It's generally to separate the main switch that the human will turn on than the actual switch. So both are the main things, but I don't want a human to turn on a DC source, an AC source which is of 220 voltage and get shocked. So for this reason, for safety measurement, I am using another small voltage source which will enable this coil and later on will complete the circuit of a large voltage source. This is a mechanical relay type element. This causes a very high noise because of its EMI, and there is also chance of high resistance, arcing, oxidizing, and this kind of conditions might melt the instrument. So for this reason, we have another what can I say, another more modern, but still it's itself ancient type, but it's more modern version of mechanical relay, that's the solid state relay. In this solid state relay, we are doing the same thing, same measure, but with a different procedure and a different purpose. No, purpose is same, but with a different procedure. So we all know that AC current travels by this part, right? This sine wave of AC current. So at first, let me make you understand the concept of track. So in over here, known to understand the concept of track acts as a switch. All right, track here you will be knowing about track many times. So just remember, track is a switch. So in an AC current, here what track will do is that my aim is that when the current will be close to the zero crossing line, the track will be turned on. After it crosses the zero crossing line, the track will be turned off again. After it is close to the zero crossing line, it will be turned on, and after it crosses the zero crossing line, it will be turned off again. So this is allowing the current not always to get through this whole sine wave. So what is the advantage of it? It will reduce the EMI and it will also reduce the extra noise, as it is always being triggered when the current is close to the zero crossing line. So now let's get to the mechanism. Our main aim is to trigger the current when the zero crossing line is about to come, so that less sound is being produced and can overcome the disadvantage of mechanical relay. So here we have connected a heater with a voltage source, and here is this snubber circuit. We all know what snubber circuit is. I need not explain it, but still I'm explaining what snubber circuit is. This literally the extra voltage which may harm our system. It's passed through this snubber circuit, so that there is a resistor out there, there is a capacitor out there. It will not harm the overall heater or the overall circuitry. So what we are having here is A, B, C. This represents A as a phototransistor, B as the zero crossing detector, and C, this will be the trick. So our main aim will be here, suppose a voltage of plus 5 volt. When I can give plus 5 volt, but I cannot give plus 20 volt. 220 volts. 220 volt directly turning on and off by my hand. It's you know, it's very complicated as well as very risky as well for me. So here will be plus 5 volts that will be turned on by my hand. So plus 5 volts, there will be a resistance of 150 ohm. Don't need to understand what it is. Just know here will be a resistance. There will be an LED. Okay, this will be the LED, and this will be directly connected to the prop. So very easy, right? Another thing is that there will be an output pin that will be connected. So there's a base over there. This is burning by this way and will be going by this way. This is emitter. Just ignore this. This is a transistor that. So only when I'm turning, so this is an output port which is connected with the microcomputer type. When the microcomputer is giving the output to transistor, the base circuit is being turned on, thus the current is being passing through it, which turn on the LED. When the LED is turned on, the phototransistor will detect the LED has been the LED has been turned on. Now, when this LED has been turned on, the phototransistor detected that LED has been turned on. So now B will tell the phototransistor, okay, inform it to me when the current that's been passing through it will be close to 0% line. So B will detect when the current is being close to 0% line. Okay, so the B will detect the current. Okay, the current is close to 0% line. C, the current is close to 0% line. Okay, C will then inform to the track and turn on the track. When the track is turned on, the voltage source will be active and the current will pass through. Okay, now another thing. The current is close to 0% line. Here, it will be active. Alright, because it's close to 0% line. Now, after completing the cycle, it will be again turned off. So this track will be again automatically turned off. I need not to do anything. Again, when it will be close to the 0% line, it will be turned on. Again, when it will cross the 0% line, it will turn off. So in this is the whole mechanism. The whole mechanism of how the system works when it's in a solid state relay, and how solid state relay overcomes that large noise that's been produced from the mechanical from that of the mechanical relay. And besides this, we also cannot find any mechanical contact over here that we found over in the mechanical relay, which causing the high resistance to melt down our instrument, which we do not want. And it's also the mechanism is quite hard to understand or comprehend, but the system of the circuit is quite easy and less complicated. You know, just adding up two circuitries in the mechanical by the mechanical force. It's a bit of its concept is easier than this, but the mechanism is a bit complex and unreliable than this one. But there are disadvantages. It's expensive. There is also a significant voltage drop, as I am not getting the full voltage over the AC circuit. Then we also need to jump to several voltage opposing track, and sometimes many unwanted incidents may also happen, which we always need to be careful about. Okay, thank you. So this is a very important video, and share this with your friends and also other peers who are studying computer interfacing in their bachelors.